We will now continue with section 2.4 and discuss perpendicular lines. Let's consider the slopes of perpendicular lines. Recall that perpendicular lines are those lines that cross and form right angles of intersection. So these two lines would be perpendicular as long as we have a right angle where the lines intersect. The slopes of perpendicular lines. Suppose M1 and M2 represent the slopes of two lines. The two lines are perpendicular if and only if M1 is equal to negative 1 over M2. What this means is that if you have your lines and you have the slopes need to meet two criteria. The slopes need to be reciprocals of each other, which is what they're saying by saying M1 is equal to 1 over M2. So you need to have a reciprocal relationship between your slopes. And they also need to have opposite signs. So one needs to be positive and one needs to be negative. If those two criteria are met, then your lines are perpendicular. So for example, if you have one slope of a line that's equal to 3/4, and you want a slope of a line perpendicular to that, then you need to do the reciprocal, which will be 4/3, and you need to make it have the opposite sign. So it would be negative 4/3. So let's look at a couple of examples. For each line given below, find the equation of a perpendicular line. So if you look at part A, and remember that part A is written in slope-intercept form, which recall slope-intercept form is y is equal to mx plus b. You know that the slope lies here in front of the x. So the slope of this line is negative 4/9. So if we are talking about a line that is perpendicular to this one, what would the slope be? Remember, we have to meet the two criteria. So we have to do the reciprocal, which would be 9 over 4, and we have to change the sign. And so this one is negative. We would need our new one to be positive. So we have the slope. We can go ahead and kind of write our equation. We're going to put it in slope-intercept form just like the other one. So y is equal to, our slope is 9 over 4 x plus, and I need a y-intercept. And really, I can use anything in this case for my y-intercept because it just says give me a perpendicular line. So I'm going to choose 7. And so now I have an equation of a line that is perpendicular to the given equation. Part B says that we want the line passing through the points negative 1, 3 and 4, 1. And we want something that's perpendicular to that. So remember that in order to write a perpendicular line equation, we're going to have to know the slope. So let's take our 2 points, the negative 1, 3, and let's label it x1, y1. And the 4, 1, let's label x2, y2. And let's calculate our slope. So remember, our slope is the difference in the y's divided by the difference in the x's, or y2 minus y1 over x2 minus x1. For the y2, I'm going to plug in a 1. For the y1, I'm going to plug in a 3. For the x2, I'll plug in a 4. And for the x1, I'll plug in a negative 1. So 1 minus 3 is negative 2. 4 minus a negative 1 is 5. So we know that the slope of the line that passes through these two given points is negative 2/5. Now I want to write an equation for a line that is perpendicular to that. So what would the slope of my equation be? If the slope of this one is negative 2/5 and they're perpendicular, we know that we have to meet those same two criteria. So we'll do a reciprocal, which will be 5/2, and we'll do an opposite sign. And again, this one is negative, so this one needs to stay positive. So let's write an equation for a perpendicular line. We're going to write y is equal to mx, so 5/2 x, plus, and you can select again any y-intercept that you want. So I might pick the number 3. And now I have an equation of a line that is perpendicular. Y is equal to 5/2 x plus 3. Our next example says, find the equation in standard form of a line that passes through the point -313 and that is perpendicular to the line y is equal to -7. Now, it is possible that this could be a very easy problem to work if you recognize that this line, because it only has one variable, is either horizontal or vertical. And remember further that if the only variable that you have is a y, then that makes that a horizontal line. So think about what this graph is going to look like. I'm just going to do a real quick sketch here. If I have y is equal to -7, then my graph is going to be a horizontal line down here at -7. Now, I want a line that's perpendicular to that goes through the point -313. So let's go ahead and plot that point, -313. So here's -3. And 13 is going to be way up here. I'm just going to kind of estimate a little bit, and I'm going to place my point. So we'll make that the point -313. So think about what this line is going to look like. If it's perpendicular to the red line and it passes through that point, then the line is going to have to do something like this. And so that line is a vertical line. And so the equation of a vertical line also only has one variable, but it has an x. And what is x equal to? Well, for every point along this line, the x is equal to -3. And so our solution there for the perpendicular line is going to be x is equal to -3. So that's kind of a special case because we're dealing with a horizontal and a vertical line being perpendicular to one another. We're going to look at a similar example where that's not the case. So find the equation in standard form of the line that passes through the point -4, -12, and that is perpendicular to the line 6y plus 2x is equal to 1. So let's start with our given line. Our 6y plus 2x is equal to 1. Now, I'm going to go ahead and put this in slope-intercept form, which means I'm going to solve it for y. So I'm going to start by subtracting 2x from both sides, which is going to give me 6y is equal to 1 minus 2x. Then I'm going to divide each term by 6. Which is going to give me y is equal to 1/6 minus 2x over 6, which I'll worry about reducing in just a minute. I'm going to switch out the order so that the x term comes first. So -2x over 6 and positive 1/6. So as I'm looking at that equation in slope-intercept form, what is the slope? Remember that the slope sits in front of the x in that format. So my slope of this line is negative 2 over 6, which we know reduces to negative 1/3. Okay, so let's talk now about the line that we want to graph, or the line that we want to write an equation for. What do we know about that line? It says find the equation in standard form of the line that passes through the point. So we definitely have a point for our new line. We know that it contains the point negative 4, negative 12. Do we know the slope of our new line? Well, we know the slope of this line, and we know that the two lines are perpendicular to each other. So if the slope of this one is negative 1/3, the slope of this one will be the reciprocal of 1/3, which would be 3, and an opposite sign. So if this one's negative, this one needs to be positive. So now I know a point and I know the slope. And I remember from the last section that I have the point slope formula. Y minus y1 equals m times x minus x1. My point will be the x1 and the y1, and my slope will be the m. And so let's plug in. For the y1, I'm going to put the negative 12. For the slope, I'll put 3. For the x1, I'll put the negative 4. So I have y plus 12 equals 3 times x plus 4. Note that it's asking for the equation in standard form, which means that we want the ax plus by is equal to 0. All right, so let's go ahead and distribute the 3. So y plus 12 is equal to 3x plus 12. All right, I'm going to subtract the 12 off here because the number will need to be on the right. But notice that when I do that, it falls off of both sides, leaving me just y is equal to 3x. So then I'm going to subtract the 3x from both sides, which will bring the variables to the left, which is what I need for standard form. So I have negative 3x plus y is equal to 0. And that is standard form to have your x, your y, and your number. Our last example is kind of a summary example for the entire section. It says that we are given two pairs of lines. We want to determine if the lines are parallel, if they're perpendicular, or neither. And the answer to this is going to rest on the slopes. Remember that if the slopes are equal, then the lines are parallel. If the slopes have that opposite sign reciprocal relationship, then they're perpendicular. If they don't meet either of those criteria, then they would be neither. So let's look at our first example. Our first line is 3x minus 7y is equal to 12. I am going to take that equation and I am going to write it in slope-intercept form, which means solve for y. So I am going to first subtract the 3x from both sides, which leaves me negative 7y is equal to 12 minus 3x. I'm then going to divide all three terms by 7. Actually, let's divide it by negative 7. Which is going to give me y is equal to 12 over negative 7 plus, the two negatives make a positive, 3x over 7. So remember that in slope-intercept form, your slope sits in front of the x. So your slope in this equation is going to be 3 over 7. So I'm going to write that here so we don't forget, 3 over 7. And then we're going to do the same thing for the other equation. Go back to that, sorry. All right, so let's look at the other equation. 14x plus 6y equals -5. We're going to solve that for y. We're going to subtract the 14x from both sides, which gives me 6y is equal to -5 minus 14x. We're then going to divide all three terms by 6, which gives me y is equal to -5/6 minus 14x over 6. And your slope in this case would be -14 over 6, which is going to reduce to -7 over 3. And so if you look at your two slopes, 3/7, -7/3, you see that they are reciprocals and they have the opposite signs. So these two are perpendicular. Now for part B, the equation looks terrible with those fractions, but in actuality, it's not so bad. We are going to check and see if the lines are parallel or perpendicular. So let's look at the 2 points that we have. We have the line that passes through the point 0, 4 and 2, 22. Let's look at that first and let's calculate our slope. So our slope would be the difference in the y's and the difference in the x's. The 0, 4, we're going to make x1, y1. The 2 and 22 will make x2 and y2. And so for the y, we're going to have 22 minus 4. For the x's, we'll have 2 minus 0. 22 minus 4 is 18. 2 minus 0 is 2. The slope is 9. Now, if you look at your first equation, you can see that even though it's not really simplified, as we simplify it, we're going to distribute that 9 through that parenthesis. What number is going to go in front of the x? Right, a 9. And so we're going to have a slope of 9 for the first equation and a slope of 9 for the second equation. So that means that the lines are parallel because we have equal slopes. For our third example, what are your slopes? Both of these are in slope-intercept form. So we have a slope of 3/4. We have a slope of 4/3. The slopes are not equal, so they're not parallel. And they don't have the opposite reciprocal nature. They are reciprocals, but they're both positive. So these two lines are neither parallel or perpendicular.